Okay, let's dive right into this. Today, we're tackling a topic that honestly feels a little bit like sheer magic. I mean, we've all been there, right? You type this massively complex question into ChatGPT or Claude, and you just watch in awe as this perfectly crafted, brilliant response scrolls across your screen in literally seconds. It's so tempting to treat these tools like they're people, but the truth? It's just math. It's patterns and an absolutely unimaginable amount of data. So let's pull back the curtain and demystify exactly how these massive AI models are actually working behind the scenes.
Section 1. The ultimate word game, predicting the next word. So, to really wrap our heads around how these tools function, I want you to think back to a simple childhood game. Listen to this phrase. The sky is... Go ahead and finish that sentence in your head. It didn't even take a fraction of a second, did it? You didn't have to run to a library or look up the definition of a sky. Your brain just instantly jumped to the answer purely based on a lifetime of experiencing the English language.
And of course, the word that popped into your head for sure was blue. You hear once upon a, and your brain instantly yells time. Well, this super simple concept, basically being the absolute best player in the world at guess the next word, is the actual fundamental core of how these incredibly advanced AI models function. They are, quite literally, just filling in the blank.
But, okay, let's scale that game up massively. Imagine a system that has played guess the next word on pretty much the entire digitized internet. Every book, every article, every random blog post ever created. They've consumed and analyzed the whole shebang. It is the exact same guessing game, but it's performed at a scale and sophistication that actually produces genuinely useful, coherent answers. And this is exactly what a large language model, or LLM, is. It's an AI trained on massive amounts of text data with one very specific goal: to predict and generate language. And what scientists discovered is wild. If you build a system whose core skill is predicting what word should come next, and it does that skill exceptionally well, an incredible thing happens. Suddenly, out of nowhere, that system can write computer code. It can draft high-level essays. It can hold a completely natural-sounding conversation with you. Let's move to Section 2 and see how this builds. Breaking down tokens, the building blocks. Lifting the hood here, we can see this is basically a three-step process. Step 1, like we just talked about, is training on massive text. The AI digests everything to learn the statistical relationships between words and ideas. Then we hit Step 2, breaking all that language down into manageable little pieces. And finally, Step 3, the generation phase, where the model actually predicts the next piece of the puzzle. Let's zoom in on that second step for a minute. Now, what's really interesting about this is how the AI actually sees language. It doesn't read whole sentences or paragraphs at once like we do. Instead, the text gets chopped up into these tiny chunks called tokens. A token is often just a piece of a word. So when the AI is writing a response to you, it is quite literally calculating and predicting one token at a time, one after another, building your response step by step. It's using math to find the most likely next puzzle piece based on all those statistical relationships. Section 3, predict versus retrieve, not a database. So the crucial point is right here. This might be the most important takeaway of this whole explainer. The biggest myth out there is that chatbots know facts like an encyclopedia. We tend to picture them as these giant databases where facts are just safely stored away in digital filing cabinets. But they don't pull verified answers from storage. Reality? They dynamically generate text based on learned patterns. It's honestly like a highly sophisticated version of your phone's autocomplete, just trained on a mind-boggling amount of data. Just think about how you use this in the real world. When you ask an AI to summarize a dense historical topic, or explain a complex scientific concept, or even just draft a quick email to your team, it isn't pulling a pre-written answer from some hidden file. It is dynamically generating every single piece of that response by predicting the most statistically likely next chunk of text, based entirely on the prompt you gave it and the patterns it learned. Which leads us to our final section. Section 4, hallucinations, real limitations. And this brilliantly illustrates a very real limitation we have to talk about. Because the model predicts rather than retrieves, we get hallucinations. A hallucination is when an AI generates incredibly confident-sounding but entirely factually incorrect information. And here's why understanding the mechanics is so crucial. A hallucination isn't a glitch. The system is not broken when it hallucinates. It's actually doing exactly what it was designed to do, predicting plausible-sounding text. The mathematical statistics just happen to string together a beautiful sequence of tokens that sound totally believable, but are completely 100% wrong in the real world. So let's do a quick recap to tie all of this together. Large language models generate remarkably fluent text. They do it by predicting the next token over and over, leaning on patterns from massive amounts of training data. But, and this is a big but, they do not retrieve stored facts. They predict plausible text. And because of this, they absolutely can and will confidently generate incorrect info. This is exactly why fact-checking matters. You are the ultimate safeguard. It's totally on us to double-check those important dates, figures, and facts. Which leaves us with this final, crucial question to ponder as we wrap things up today. Next time you use an AI chatbot for something important, what is one fact you should absolutely double-check before trusting it? Keep that top of mind, and you'll be well on your way to harnessing the incredible power of these tools safely and effectively. Thank you so much for joining me on this explainer. I really hope it cleared up the magic behind the machine, and I'll see you next time.